Someone knows?
Okay, what happens is you need to stop turning it off, but it'll turn back. It'll turn on in a second.
Okay, let's see.
There you go.
So I'm going to drive back to LA but I usually like late on Sunday. I'll drive back there.
Oh, cool. Yeah, we're going to go to San Francisco for dinner. That's good stuff. You normally live in LA?
Yeah.
Cool. I'm from Manhattan Beach originally, so I'm out there periodically.
So,
cool. Be out there for 4th of July.
yeah. I wonder if it gets this larger, since I have some codes that I doubt one can see on the one side and the other. Maybe you can try. Maybe put it on another table. Yeah, it might be that sometimes the font is a little small, so if someone cannot read, please tell me. And yeah, this talk is about Haskell in the browser with Haste. And well, let me first go to this slide. Can you read this? No, probably not.
Well, if the lights are off, it'll be easier.
Yeah. Does it look better? Or maybe we can make it harder. That's too big. Okay, yeah. So while I talk, so if you want to try out Haste, so we have to see. Depends a bit on you. If you make it more like a class and you try, someone, not sure, some of you have laptops. If you want really to try it out, Haste and compile stuff. I might not be able to finish everything on the slides, but it's fine with me. So if you might be able to run Haste in the end. So it's up to you. So or stop me at any time. So yeah. So I the code that I will talk about is on this JIT repository. You can just clone it. The address is on every slide. So. You don't need to hurry, and the build instructions are in the README file of this repository. So it's all in a single cabal package. And and if you try it out, well, this stuff here, it's a hint. So I have to put it there for me to compile. I tried it out on a clean Linux VM. It might not be needed on your setup. It depends a bit like what you have in your package database, or not sure. So.
Would you read that URL? I have actually have 2020 vision, but that's just
it's github.com, Aleph Cloud.
Aleph Cloud.
Yeah, Aleph Cloud. Maybe can we do? I think that's Aleph Cloud / BayHac, BayHac 2014. And so there's a fair chance that no one will have Haste installed by the end of this class because first thing, it's a cross-compiler, and my colleagues always complain that Haste is too complicated to handle. Well, I never worked with a C cross-compiler that was easy to handle and worked out of the box. So I try hard to make this instruction that you have a fair chance to get it run on a clean Linux VM. Try it out, and for example, here this is well, you need a modern SED, or you edit the file with or a GNU SED, or you edit it from hand. So this solver thing, I had to put it in when for booting. If you clone Haste from GitHub, it might work without. But my version that I had needed this thing to put during Haste boot. So yeah. Okay, so this talk. First thing, this talk is not about Haste. The reason is I know very little about Haste. This talk is about using Haste, which yeah. So I'm interested in Haste only as much as I need to get it running. So please don't expect any low-level stuff, how Haste generates code or whatever. I know very little about that. The next thing is this talk is not about really web front-end development, because in our company we have web developers who do the UIs, and they use JavaScript probably as most UI browser developers do, and part of it is even outsourced to other companies. So this talk is about mostly doing or we use Haste for compiling libraries with JavaScript. So we are in a situation where we have a lot of cryptographic code, and our UI programmers are not cryptographers, so we don't want them, or they don't want to write cryptographic code. And we have relatively small number of people writing cryptographic code, and we want them, and they write Haskell code, and they write it on the backends and the servers. But for cryptography, there are certain operations we have to do on the client side. We cannot do them on the server, so we need to we need to run them in JavaScript. And since this cryptographic code is really, it's the core IP of our company, we try to keep the code base small, and the number of people working on them small, or well, at least concentrated. And so this is the idea of, well, let's use our Haskell code base on the browser. So we essentially try to do systems programming in the browser and develop libraries for the browser, not really front ends. And this is a bit different from, I think, what most Haskell JavaScript compilers do, or even Fayos. So they are usually more focused in really do UI development. They do DOM manipulation, something we don't do at all. Yeah, so in Haste, for example, in a lot of part of the development in Haste goes into this direction of having kind of developing a monolithic application with a server and client component, but developing in a single code base, writing everything in Haskell. We don't use it that way. So essentially what I tell you is a bit kind of a non-typical way to use Haste. But I think it's valid anyways, because nowadays it seems that browsers are more and more becoming kind of lightweight operating systems, and we are starting to do more kind of systems-like programming in the browser. So it might be still interesting, I hope. But yeah, I'm sorry, don't expect any DOM manipulation or UI stuff. Okay. Yeah, and if you run into issues, feel free to interrupt me at any point with these instructions here. Most likely I cannot help you, but maybe.
We're not really getting the left-hand edge of the text. It does the shadow.
Sorry, which?
That shadow is part of the projector, unfortunately.
Yeah, I don't think. Yeah, I probably have to live with it. Okay, so yeah. So the topics of this talk, I will make in two parts. The first thing is really just setting up and using Haste. And this is very, very basic, but at least for me, it's a good part of using Haste. Kind of most of the time I deal with those issues. Usually once you have it set up, you're good to go, then it works. But setting it up, every time there's a new version, you run into issues. it's a cross-compiler, so weird things happen. And the second part is about how we develop libraries, and the focus is really on libraries and not monolithic applications. So we have to integrate this existing JavaScript code and provide APIs for our front-end or UI developers. Okay, so that's the first part, and so there we'll talk about, well, how to install and set up Haste, compiling and deploying an application. I will show you how to do this, and how to do foreign function calls with Haste, and well, but how Haste does marshalling of data. You need to know this when you want to do non-trivial foreign function calls and interact with JavaScript. So, set up Haste. Well, if you go to the Haste web page, it tells you you should type cabal install Haste compiler and Haste boot. For me, this never worked. You can try it. Maybe you're lucky. So the following sequence worked for me yesterday. So you might try this out. This constraint on scientific, it's completely unrelated to Haste. It's related to some dependencies. So yeah, you cannot really blame Haste for this. It just so you can try this out. If you run dishes, try this constraint on scientific and you might disable, if you want to get any results during this class, disable documentation and profiling libraries, because it takes a long time. And yeah. Oh, by the way, I recommend doing this in a, if you look at the README in this package, do it in a sandbox. So the whole thing. This will install Haste in a sandbox, but the Haste compiler itself won't use a sandbox. So Haste is installed into a sandbox if you run this in a sandbox, but the Haste compiler itself won't be in a sandbox. So yeah, oh, well, yeah, and look at the README. It describes there. So when you once you compile your first Haste program, disable the sandbox by just rename the sandbox configuration. Okay, so here is Hello World with Haste or Hello BayHac. It's just a Haskell program. Well, the alert is especially could put their print statement, but then would get it only to the JavaScript console. Alert will print it. So it's really just the import Haste. This Haste module provides the alert call, but it's just printing something. You compile it with this Haste C. It's a Haste compiler. You give it the Haskell module, and it compiles the compilation. Compiles it into a JavaScript application, and well, we can run it just by having a very simple HTML file, this JavaScript file in there, and the standard way how Haste compiles it compiles in a way that when you load the file, it will immediately start executing the main function. And well, here's an example what we get if we do it. Oops. Seems like something weird happened. Try again. Okay, so this worked. And if we look what happened, well, let's go back. So, and well, let's quickly take a look at the program that was generated. Essentially, what we do is, I have the code here. Oh, by the way, these test programs are in the contrib subdirectory. So if you want to try it out, so we can compile it. We do Haste C. Was Hello World BayHac. It compiles it. And if you look at the program that was generated, it generates this JS file, and you see there's a runtime here. This is a Haste runtime. It's not minified, so it's rather small. I think when you minify it, I'm not 100% sure, but I think it's well below 100K. So it's really a small runtime that Haste needs, which is really nice compared, for example, to GHC.js, which has a huge runtime. So Haste has kind of a very pragmatic approach there. They maintain kind of the Haskell semantics, but they don't try to simulate the GHC runtime. So you get a really small runtime, and in the end, the program is just what you see here in the very end. So this is a Haste program. The rest is a runtime. And
so does Haste, like, is it trying to minify the JavaScript it generates as well, or generate unminified JavaScript?
it generates unminified JavaScript. It's kind of already a bit kind of well, Haste internally uses GHC, so it does generates the core. It does all the optimizations are done by GHC, and only the code generation then generates JavaScript. So the code is already kind of cryptic. Well, it's not so bad. And there is a debug. You can pass a debug flag, then you get even code that is more annotated, less minified. But yeah, usually you want to run a minifier on top of it, or Google closure or something like this. Okay, so yeah, so if you look at the generated code, so this runtime, there are a few things that are helpful to know, because if you really work with Haste, sooner or later you have to hack into this runtime, and it's easy to do because it's really a relatively small piece of JavaScript. But the most crucial thing in the runtimes, well, it's Haskell, so we need to simulate, or it needs to simulate chunks. It has lazy semantics. So a chunk is essentially encoded in the T. So if you look in the generated Haste code, you will find these T's everywhere. Essentially, it just wraps a function, and when you evaluate the function, it just puts a value there instead of the function. So it's, defaults are not so important now. Then there is a function to evaluate a chunk into head normal form. If it's already evaluated, it's a no op. And